That snow disappeared fast, didn't it?
Boy, oh boy, it sure did.
Okay, I suppose whenever whoever is beginning is ready to go, I think we're ready to go.
I'm going first, Pete. My computer's getting angry from the number of loops and tabs I have up, so I'm just trying to close stuff out real quick.
Welcome to my world. That happens to me all the time.
Testing its ability to run all these loops. All right, let me kill this. Oops. I'll get there in just a second, Pete. Sorry.
It's okay.
Okay, let me share. Are you able to see my screen now?
We are.
Yep.
All right, I'm going to get started because there's a whole lot of fun stuff to talk about with this event. So I'm going to start off with some of the bigger picture of this event, and then I'm going to pass the baton over to Andrew, who's going to talk a little bit more about some of the specific ingredients for the tornado aspect of this event. So as probably most people are aware of, there was a big severe weather event in the Southeast a couple of days ago. I didn't actually put the date on there, but it was on the 17th. So just to start with the impact, this major severe weather event primarily was focused in Mississippi and Alabama, where you can see a diverse range here of severe types of severe weather with multiple tornado reports across many parts of Alabama, and then strong winds, 60 kilometers in. Sorry, can you hear me?
Just lost you for a little bit.
Okay, my screen just froze. Okay, so the hopefully this isn't a problem. Okay, so we've got the tornadoes across Alabama. We've got the wind reports across much of Mississippi, including some hail, especially over northern Mississippi. And this event was quite well forecasted. Many days out, there's alert on the potential for severe weather over this area. And it warranted the relatively high region of high potential for severe weather issued by the Storm Prediction Center. And if we overlay much of the reports, you can see that the concentration of many of these severe weather reports were in this region of the high storm potential. So let's just kind of focus on a few of these different categories. So if we focus first on the tornado impact, they did hone in on the greatest chances being near this Mississippi-Alabama border. But again, there were some outside of that major area, but this was a very well forecasted event. And we'll talk about some of the larger ingredients that really was conducive for this in terms of at least severe weather and discrete supercells expected to be in this region. And I just took one screenshot of many, many videos that you can find on Twitter. But this was one example of a screenshot of a drone that had gotten some video footage. And just in the interest of time, I'm not going to play the video, but really, really incredible footage of one of the many tornadoes that occurred in this region. From hail, hail was a little bit less plentiful, but again, there was some hail reports, including some near golf ball size hail in regions of this in particular was near western Alabama. And then the winds, this was the most widespread impact. So here you can see the winds distributed mostly along what we'll see was the squall line that moved across. And then additionally, especially in northern Alabama, ahead of the warm front, you can see the also impact of rainfall. So there was also quite a bit of flash flooding. So this was a really far-reaching event with a lot of different impacts. So some of these totals you can see here, nearly 5 inches in 24 hours, especially across northern Alabama. So just to very briefly go over some of the larger scale setup for this event. So this is 300 millibars at 18Z on the 17th. So you can see here the upper level jet streak. You can see the upper level diffluence over this region and some areas of large scale vertical motion indicated here in this region over Alabama. Sorry, there's 2 of us talking in this house at the same time. Apologies if I'm a little scattered. So we have upper level diffluence. We've got large scale vertical motion over this region at the upper levels. In the mid levels, what this plot is showing again is at 18Z. We've got the height contours, we've got the temperature and the wind. This label is incorrect. I switched out the plot at last minute, but you can see this upper level low, mid level low sitting over Oklahoma. And these strong winds heading out of the southwest. So we'll keep an eye on these winds because as we'll see, there's strong vertical wind shear over this region, over the southeast. So now if we go down to 850 millibars, what you can see here, now you see the influence of the low over the Oklahoma region. And then just to point out here, the dew points, rich, moist air coming in from the Gulf, as you can see here, primarily from the southerly winds into the region. So this large scale setup, that was forecasted well and was what was pointing to this region, especially in Mississippi and Alabama as a region of discrete cells and also potential for wind damage ahead of what we'll see as a cold front. So this is kind of the transition into looking at just the broad scale surface map showing the WPC fronts. And then they hatch and color in areas of likely severity, which is shown in the darker red. So if we just walk through time, this is 12Z now on the 17th. You can see a cold front draped over Oklahoma and Texas, where there was a line of convection that initiated just out ahead of the front. There was this warm front that was draped over this region. There was a long period of heavy rainfall and flash flooding occurring, for example, over the Memphis region. And then if we go forward in time, you can see the progression of the low, the cold front moving eastward. And then you'll notice that this warm front is relatively stationary, draped across northern Alabama, which will be a focal point a little bit later in Andrew's discussion. And then by 12Z on Thursday, you can see this is pushing out over the region and was responsible for some widespread convective activity and a few severe weather reports over South Carolina and into Georgia that occurred yesterday. So if we look at, this is now focusing again at 18Z, you can see here theta E is the field contours, and theta E advection is outlined in the red. And again, this is just really highlighting this warm, moist air ushering in from the Gulf, from the south. And if we look at the radar, just a snapshot, this is at 16Z, so a little bit before that. But what I want to highlight here is you can see the line of convection just out ahead of the cold front, the more widespread precipitation that was relatively stationary draped across Tennessee and producing a lot of widespread heavy rainfall. And then it's this warm sector that was the focal point in this area as you had the warm, moist air destabilizing the atmosphere. That was going to be the hotspot location for forecasted discrete cells, which could be tornadic. This is a really fantastic visible satellite loop. And it started around 15Z and it's going to go through to about 0Z. And overlaid are GLM lightning flash rates. And again, this is the visible satellite loop. So you can see a lot of the convective activity in more of this linear fashion right ahead of the cold front. And then again, you can see indeed there was a lot of convective activity that formed in this warm sector. You can see the active lightning associated. So there's a couple rounds that are going to be of note here. First, you'll see we'll wait till this loops back. First, you'll see some of the convective activity forming over Alabama, and then there's this second round kind of focused here in southeast Mississippi that moves into Alabama as the evening goes on. So I'm not going to go too much into the details of how this was forecasted, but if we look at the composite radar reflectivity from models, so we've got the NAM and the HER on the, oh, I ended up copying the exact same one. This is what happens when you do this too quickly. So what I did originally have the HER forecasted here, but the point is the models did a pretty good job capturing the location and timing of this, including the more discrete cells that form out ahead of the line over the area. So overall, big picture, there was a fairly good job on the forecast here and the timing. So let's look a little bit at the soundings. This is a little bit further west. So this is kind of near where just out ahead of the cold front. This is Shreveport. This was at 12Z. So you can see a lot of instability here. You can see Kate values increasing to 2,000 joules per kilogram, and the forecast it to be much higher, minimal SIN, and this was and deep layer shear that was observed back by where the squall line formed. But I want to focus a little bit more on Jacksonville to start, and there's a 12Z sounding, and they also launched additional soundings at 18Z. In the many regions across the Southeast. So it allows us to look at the 6-hour evolution instead of the typical 12-hour evolution of the soundings. So just to point out a couple highlights here, again, you can see the deep layer of instability that it increases with time. You can see the minimal SIN, or the SIN that was present at 12Z was eliminated. So you can see the afternoon heating and the destabilization. So even surface-based parcels had CAPE approaching 25 joules per kilogram by 18Z when things started to form. If we look at the winds in the photograph, if you can see early on, you can see the turning and the directional and the speed shear. But this really starts to become enhanced. And here you can even see a 50-knot wind just above 850 millibars. So in terms of the broader deep layer shear, the instability, there's more on here than we have really time to go for, but the SBC soundings calculate a lot of additional parameters for you, and including some of their composite parameters that take into account the instability and the shear at different levels to provide these supercell composites and the significant tornado parameters to provide some sort of numerical indication of the likelihood of severe weather, which increases as the day went on.
Angela, John here.
Yeah.
Really interesting soundings, the Jackson sounding comparison, especially. It strikes me that there's regions of differential temperature advection in the vertical layered, especially at 12Z. It looks like there's veering of the winds from maybe 800 millibars to 700, and then there's backing. And then the backing is even more dramatic around 650 at the 18Z sounding.
Yep.
And then the lapse rate really gets steep in that 700 to 525 layer. And man, all of a sudden you get this large, huge amount of positive area in that layer that wasn't there 6 hours earlier.
Yeah, that's a really good point, John, to highlight. I mean, you can really see the steepening lapse rate occur in that area of backing right here. Yeah, thanks for pointing that out. There's a whole lot to go into. Andrew and I were talking about that. We could probably talk about this for hours, but that's a really important feature to point out here. And later, which isn't going to be observed in the soundings, Andrew's going to talk about some of the backing of the winds later on in the lower levels. But yeah, thanks for pointing that out, John, that you can really see that impact here in the mid levels.
Yeah, thanks.
So then in Birmingham, just moving a little bit further east, a relatively similar story. There was a little bit more inhibition earlier in the day, but still you have the seat and level lapse rates and the instability available. And you can see also the turning of the winds, which increase, the low level wind shear really increasing over the course of that 6 hours in this favorable environment. So again, just you don't see as much of that strong backing and the steepening lapse rates. More of that upper level forcing was a little bit further back towards the west, whereas Birmingham's a little bit more on the east end of some of that upper level forcing. So just more spatially talks about what we just talked about from those two soundings at 18Z. So this is the surface-based CAPE and the red contours. You can see really high values across this region, exceeding 2,000 joules per kilogram. And then you can see by this time, most of the surface basin has been removed. There's some, though, you'll notice that's still oriented just ahead of that boundary. But you'll notice, too, that the CAPE really maximizes here, especially around southern Mississippi. And this is largely responsible to some clearing that we see that was localized throughout the afternoon. But I just wanted to bring this up because not everyone may be as familiar with some of the parameters that we would look at on the soundings. One of the variables that we were looking for in terms of the convective activity was the effective bulk shear. So what this is really the maximum bulk shear that's available from the most unstable lifted parcel. And you can see here at the same time at 18Z, there's values broadly across this area over 50 knots. And just if you look kind of at the statistics of values of effective bulk shear for different levels of intensity, you can see this layer fall, the 50 knots falls within the median of a significant tornado. So really favorable large scale shear environment. And you can see also the large effective bulk shear back to the west in the vicinity of the right out ahead of the cold front. And then another parameter that we'll look at, especially if we want to think about tornado genesis, is the low level storm relative helicity. And again, this is at 18Z, and this does change a little bit and becomes pockets more localized with time. But just very broadly at this level, you can see values, you know, 100, greater than 100 meters squared per second squared, that at least is indicative to support some sort of tornadic activity in this region. So not surprisingly, tornado watches were issued by the Storm Prediction Center, where in particular, it's just a particularly dangerous situation, expecting severe storms and a few intense tornadoes in this region, based on the things I just talked about, thinking about the instability, the bulk shear, and especially that storm relative helicity that was expected to increase with certain with time. And you can see this watch was extended for up until about 7 o'clock in the evening in this region. So this is the 16Z, but one of the reasons I want to show this is that this is a Wpc Front Analysis, and you can see the surface observations just a little bit more clearly here. So you can see, you know, dew points in the upper 60s, just a really moist environment. The shading here are high relative humidities. You can see the stationary boundary that's draped across northern Alabama, which is a really limiting factor in the northern extent of some of this, the most moist air. And you can see the streamlines here moving northward over the Gulf. And one of the things that we've been talking a lot about in 453 and 753 are mesoscale boundaries and the mesoscale organization of convection. And what I want to show here is one of the 1 minute GO satellite loops. This is just over the course of 10 minutes around this time. But you can see the cloud streets streaming in from the Gulf, and you can see the upper level clouds moving more off towards the east. And this is such a beautiful visible representation of the shear that was present during this case. And, you know, there's some discussion about some of these earlier storms that popped off, and thinking about, you know, what role could some of these boundary layer rules have played in some of the initial storms that formed over this region. But you can just really beautifully see this, and is also indicative of the broader wind shear at this time.
Angela.
Yeah.
On that previous slide you showed.
Which one? This one?
On the analysis one. Can you go back to that for just a second? Yeah, it's interesting that cyclone over southern, was it near the Red River Valley over there? Anyway, the troughing out ahead of it is interesting. It looks like that's a dry line right there.
Yep.
And so that's the dry line in advance of the cyclone that John Locatelli and Hobbs, right? Talked about.
Yeah, love to see a vertical cross section through that structure. Yeah, that's probably really intriguing. And then Jackson has the cold air advection at 700 millibars, so the cold advection's way ahead of the surface cold front.
Yeah.
Yeah, I'm glad you pointed that out. This surface trough was a real focal point and discussion point thinking about going forward. Yeah, thanks for pointing that out. I'll have to talk to you guys after that about what the easiest way is to do the cross section. I was trying to do that from tropical tidbits with some of the model output, but I will talk to you guys after that about what would be a good source to draw a cross section through there, because it's a really interesting point, and that was really an important focal point of a lot of the convective activity during this early period.
Mm-hmm.
So just to continue to move on with the story, now we're looking at 1930. So this is a couple hours later. So you can see a lot of the convection that was the severe, very deep storms forming. You can see clearly the overshooting tops in this region. You can see this activity that was going on in Alabama. But what you'll notice is there's some relative clearing here in southeastern Mississippi, and this ends up being really increasing the activity and of this kind of second round of deep active initiation, which Andrew's going to talk a little bit more about. And this is reflected. So this is that a static image of the visible satellite loop at that time. So this is at 19Z, and it's overlaid the surface-based Cape values. So you can see this is being reflected by some of the higher Cape values in this area that was allowed a little bit more solar insolation and heating that that wasn't quite as present here from some of the more ongoing convection. So this was a really big focal point for kind of round two of some of the initiation later on into the evening. And then this is again reflected in the significant tornado parameter. So this significant tornado parameter takes into account the low-level storm relative helicity and SIN, and what we see here is again this area in southeast Mississippi being highlighted. So just to kind of wrap my section up a little bit, so Andrew has some time to talk about his piece. We're just continuing to scale down now and looking at some more of the individual supercells that develop. So these are some just radar screenshots that I took from radar scope from the Birmingham radar. So at 1 o'clock, which is 17Z, and then a lot earlier, 1830. So you can see these discrete cells that have popped up south of Birmingham and southwest of the area with multiple supercells moving over regions in this area, including one very close to Tuscaloosa. And let's just zoom in on that one near Tuscaloosa really quick. So for those who haven't looked at radar imagery as much, just to point you to you can see the classic hook echo. You can see the velocity couplet located in that same region. So really strong gate-to-gate shear. And then if you look at the correlation coefficient, I know there's not a scale here, but these values are quite low. They're non-precipitation echo. So this very low value corresponding to this vorticity couplet is what's considered this debris signature from what's suspected to be a tornado at the ground. And again, many of these were confirmed through video and other reports. One thing that I found really interesting, so this is now several hours later. So this was an ongoing event. So this now is the Jackson radar. So you can see now these tornadic cells that had formed in that kind of southeasterly region where I talked about increased stabilization. And then as they were continuing ongoing multiple tornado warned storms, some radar indicated, some verified near Birmingham. And this is just a screenshot. This was around 4:30 Central Daylight Time of correlation coefficient. And I wasn't able to get the loop up fast enough, but this area of high correlation or low correlation coefficient had moved for roughly 70 kilometers from one of the tornadic storms. So this was a debris that was lofted in the storm way downstream in the upper levels near Birmingham. So yeah, I'll have to try to get that loop going later, but it was a really interesting upper level debris signature being lofted over Birmingham. And then to just wrap up my section, just some more eye candy from satellite. So this is a loop later on now. This is kind of the end of where we have the visible satellite imagery. So this is about 23 Z to the end. And what I did here is I overlaid the IR over top of the visible in both of this loop and the static image at 2316 Z. So you can see this incredible 1 minute mesoscale sector imagery. You can see the overshooting tops, the bubbling of the overshooting tops. And one thing I really want to point out here is you can see what's this above amble cirrus plume that you can see these really intense updrafts penetrating into the stratosphere that appear slightly warmer than its environment as the stratospheric air mixes in. And you can see these plumes that are being used as a forecast tool indicative of extremely intense convection and likely production of severe weather. And you can see the snapshot here, this beautiful example of one of these plumes. So I went a little longer, but there's just so much interesting stuff to talk about. And I think this will be a great case to analyze in more detail. But now I want to hand it over to Andrew, who's going to scope down even further to really talk about some of the tornadic ingredients for some of the tornadic cells that formed later on in the day. So let me stop sharing.
All right, thanks, Angela. I'm gonna just pull my screen up real quick. All right, I'm assuming everybody can see this.
Yes.
Okay, awesome. Let me just get this into present mode. Okay, perfect. So as Angela kind of said, I'm gonna pick up a little bit more with kind of some of the tornadic activity that went on Wednesday afternoon, particularly across the state of Alabama. And, you know, there's two things in particular that I really want to kind of look at here. Number one being the northern extent of where this tornado activity kind of occurred. And then number two, this kind of mid-afternoon mini outbreak of, you know, tornadoes in Southwest Alabama, kind of south of Tuscaloosa, north of Mobile. This was a quick map I made yesterday when I was kind of going through some of the obs real quick. So I've kind of shaded these by hour. Lighter colors were earlier in the day. This runs from about lunchtime on Wednesday through about the 5 o'clock hour. So we can kind of see you had this little cluster mid-afternoon that I'll be hitting second, but you can see these tornado reports really don't extend any further north of kind of this line of crudely drawn in through the Birmingham area. And really a lot of the features that Angela has alluded to have kind of, you know, been responsible or kind of would be the reason why those tornado reports didn't really make it that much further north. So to quickly rehash, this was our surface analysis at 10 a.m. Wednesday morning as analyzed by the Weather Prediction Center in College Park, Maryland. And, you know, we had an interesting synoptic setup ongoing. We had our low over central Oklahoma that was tied to that trough coming out of the Rocky Mountains. But we also had this stationary boundary that was probably loosely tied to actually a cyclone over the Atlantic Ocean. And it was really just kind of draped through the Birmingham area. Let me just go back there real quick. And in true stationary boundary form, it really didn't move much as we progressed through the day. So these are some screen grabs I've taken from the Storm Prediction Center meso analysis pages. And what we're seeing here is equivalent potential temperature plotted in the green contours, and then advection of theta E plotted over top in the purple. And we can see this is what the boundary looked like as analyzed at 10 a.m. And we can just really see, you know, as we move through the day, as we move, to 18Z, so to about 1 o'clock and then into 4 o'clock, this boundary really didn't move much, which it's a stationary boundary, so it's not expected to move very far. But it really kind of sheds light on why we didn't really see many tornadoes north of Birmingham, really, because once these storms kind of overrode that boundary, you no longer were tapping surface-based parcels. And once storms go elevated, once they go over the top of that boundary, which we now see as analyzed at 4 o'clock, really you're looking more at a large hail, heavy rain threat from those storms as they can't really communicate to the boundary layer. So really kind of interesting how we had that sharp cutoff, but likely was tied to this stationary boundary that was situated across the state of Alabama. But what's really, really interesting and really kind of into the weeds on the mesoscale perspective is this very locally oriented kind of outbreak of tornadoes that happened between 20 and 21 UTC on Wednesday afternoon. And this one, I guess, is not so much related to the stationary boundary that we've been discussing to this point. So I just want to back it up a little bit. What we're looking at here is the Pedersen frontogenesis plotted in the 1,925 millibar layer. So we're looking the extreme low troposphere, really just to get a feel for any sort of boundaries that are there. And not surprisingly, at 18Z on Wednesday afternoon, we can see the pearls of frontogenesis, affiliated with this stationary boundary up to the north across, kind of more central parts of Alabama. What I'd also call your attention to is we have this evolving kind of local maxima straddling that Mississippi-Alabama border. And that's perplexing because from the synoptic analysis, we know that's not really tied to any sort of frontal structure. So immediately, red flags start rising for some sort of mesoscale boundary. And as we look through the afternoon, so now to 19Z, 20Z, and then finally 21Z, we can see that this boundary remains quasi-stationary. It doesn't really move, but it does appear to, almost get stronger in strength over this 3 to 4 hour time period. And quite honestly, what this is, and where this really co-locates nicely with this tornado outbreak, is likely some sort of outflow boundary. So to the north of this boundary, you had a lot of convection in progress, really from the lunch hour up through this hour. So you had a lot of kind of cooled parcels that were polluted from prior convection residing to the north of this boundary. However, to the south of where all these tornado reports ended up blossoming on Wednesday afternoon, we had largely unpolluted air coming off the Gulf of Mexico. We can see just really, really strong southerlies coming off the Gulf. And we can even see from the surface thermal structure. So I should have said, plotted over the purple contours of frontogenesis, we have temperature in Celsius. And you can see that there is a boundary of thermal contrast here. Number one, you can see you have your trough and your isotherms to the north, where it's been raining and storming for several hours at this point. But we have a bit of a ridging effect in our isotherms to the south of the boundary, where there's been much less convection ongoing, and we just have this fresh source of moisture and instability coming in off the Gulf. So with that, we kind of had this boundary situated across this portion of Alabama in extreme eastern Mississippi. So when you've got a surface boundary of convergence like that, that's something you really want to be looking at in real time as an outbreak like this is unfolding, because that's going to be, I guess, kind of a facilitating spot for convection. And in this kind of environment, severe rotating convection at that. So just to kind of illustrate my thought process there, what we're looking at is surface moisture convergence plotted in blue. And then this is plotted over the top of mixing ratio values, I believe, in green. And we can kind of see, I've only shown this at 2 hours for the sake of time, really kind of when the tornadic activity was really getting going in this area. You can see the effects of the surface convergence in the flow field, really pooling that moisture, which we know is going to then be a local hotspot of convective instability. And in an environment that was unstable, or as unstable as what it is, I mean, really at this time, we were looking at the mixed layer CAPE in the 1,900 millibar layer. We're looking at anywhere between about 1,500 and 2,000 joules per kg of CAPE at this point. And when you overlay that, looking at the effective storm relative helicity, this is taken over the 0 to 3 kilometer layer. We have values of 200 to 300 meters squared per second squared in this area where all the tornadoes fired up. You just had all the pieces right there. And all it took was one of these little mesoscale boundaries that was in part forced not only by the southerly flow off the Gulf, but also by the cold pools of prior convection that had passed by to the north. All it really took was to get, I'll walk back to the tornado report. I counted, I think, 7 or 8 tornado reports out of the total of 21 in this outbreak on Wednesday. So, I mean, that's over a third of your activity, all kind of stemming from this little mesoscale boundary. And I think, honestly, before I wrap my part up, it's an importance to it's a testament to the importance of nowcasting. You can't really resolve outflow boundaries, in the model data on the morning of. So it's really important as these outbreaks are unfolding, that you're paying attention to the data and you're looking at where these boundaries set up, because Something as subtle as that, and definitely subgrid scale, is, largely responsible for such a sizable portion of the tornadoes in this outbreak. So that pretty much wraps up what I wanted to say. Again, we could go on for hours about this, but really interesting day on Wednesday. And, there might be several more days like this moving into the next couple of weeks, especially with the way the storm tracks are going to be setting up. There could be some more active days in the coming weeks, potentially, for the Gulf states.
Andrew, question for you.
Yeah.
Yes. First of all, thanks for the really great diagnosis both you and Professor Rao did in the discussion of this event. So I'm curious about this last point, the importance of these outflow boundaries from pre-existing convection. So as was stated by Professor Rao earlier, the convection that developed over the Southeast was pretty well forecast in terms of the area of concern, the enhanced moderate, the risks were really well outlining that region.
Mm-hmm.
But presumably there was no knowledge of a pre-existing outflow boundary that would have been in that position. So I'm kind of curious, to the extent you could imagine a what if experiment. What if somehow that boundary hadn't set up or the convection had been delayed in a particular region? Would you still have gotten about the same number of tornadoes, but just distributed a little bit differently? I mean, a third of the event seemed to be based around that boundary, but is there any way to understand, because the environment was primed for tornadic thunderstorms or, for tornadoes to be produced.
Absolutely.
The boundary had to be there. I'm just wondering from a predictability standpoint, the complexion of the event, where tornadoes originated may have been a little bit different, but would you have gotten something, a similar outbreak in terms of the size?
Yeah, that's a great question, and that's something I haven't really thought much about. I would say it's a bit of a cop-out answer. I would say the parameter space would have supported that kind of distribution of tornado reports. And as we said, it's just the fact that you had that boundary that was focusing the convergence and the moisture and the instability in that spot, such that the larger scale ingredients could be tapped there locally. But I would think based off of what we saw in terms of what was going on prior to that, we already had, we had several other tornado reports, I think 14 or 15 not tied to this area. And, I largely would have think that you would have seen more, perhaps more spatially kind of dispersed across the state of Alabama. But once that initial kind of earliest right after lunchtime round of storms kind of cleared out from the area and dropped the tornadoes they did, really you had that one main feature. And that was kind of, if I had to hypothesize, pooling all of that together. But I would guess if that boundary had not been there, you probably see a wider distribution of supercells and probably a similar amount of reports, because just the environment was incredibly conducive for tornadoes on Wednesday across that part of the country.
Thank you.
Yeah, I got a question too, Andrew. Great presentation, and same to you, Angela. Fantastic. This was great. And Andrew, I'll start with a comment. First, it's this throws the old Reagan line in the part of the country where they most sop it up into the shredder. I'm from the Weather Service and I'm here to help. Those are supposedly the 9 worst words in the English language. I don't think so. Nobody died in this event, and that's not an accident. That's a result of extraordinary advances in our science and extraordinary dedication by professionals who implement those advances. So my question is this: when those convective storms go up over the boundary in northeastern Alabama, that's really interesting. They no longer, as you said, can drag in air from the boundary layer. And that layer is probably convectively unstable. I think you even said that. I'm wondering if there's any sense at all that people have, and this could go both to you and Angela, is there any sense at all about what that does to the upper tropospheric vorticity distribution? Because my presumption is when you take convectively unstable air and you loft it through a convective updraft, you produce these lines of negative absolute vorticity. So there's substantial turbulence. And that turbulence can do damage to aircraft. It may even carry downstream toward Atlanta Hartsfield. Maybe they had some extra turbulence on approach, which would be interesting. But it also, of course, allows for great upper divergence. Really easy. And this goes to Greg's idea about when the inertial stability goes down, the air doesn't have anything to overcome to go horizontally and out the top of these storms. So is that one of the things that helps to organize these in lines?
That's a really good question. Angela, is there much in the literature on things like these? It's an interesting point that you brought up about the turbulence. I saw a tweet Wednesday morning, kind of before the tornadic part of this outbreak got underway, but storms were firing up across the southeast, and there was like a flight Birmingham to Dallas that had to divert all the way down into the Gulf of Mexico and then back up to get around the turbulence that was coming from these storms. Yeah, I mean the flight took double the time it should have because of how far they had to divert around. But in terms of the effect on the vorticity field aloft, that's something I haven't really thought about, and I don't really know if I have a good answer for that.
Okay, thanks. Great presentation.
Yeah, John, that's something sorry, I was trying to unmute. I'm trying to look up the maps on this to see if I can confirm that with the data. So I'll follow up with you on that. It's just taking me a little bit to pull that up.
Okay.
But I don't want to delay it any longer since we only have 20 minutes left if we want to move on to the next part of the discussion. Thanks, Andrew.
Absolutely.
John, are you or Michael jumping in for the forecast, or?
I had not planned to do that myself. No, I don't know if
I have a little bit to share for the forecast.
Okay.
So I can get that set up. Just a moment.
In the meantime, I can say a couple things while he's getting ready. One thing I noticed about this outbreak is it didn't seem as big of an outbreak as we've seen in other outbreaks, right? There's only 21 tornadoes, and some of these outbreaks you'll see many more than that, several factors more than that. So in some ways, I thought this was a somewhat suppressed outbreak. I don't know if you thought of it that way, Andrew or Angela, but to me, it didn't look like it was an all-out release, as we see sometimes.
Yeah, I mean, that's a good point. They went high, and they also, at like the last convective right before the outbreak started, they went 45% hatched on the TOR, outlook. And that's only the third time in history they've done that. One of the other times was April 27th of 11, which was the second super outbreak. And then the other time was a couple years ago. So very, very high end. I think the reason why it was so highly forecast is, number one, there's a lot of sensitivity to tornadoes in that part of the country, especially after what happened in 2011 and in 1974. And also the metropolitan areas. I know Angela and I were discussing that this morning. You had Tuscaloosa, you had Birmingham, kind of at ground zero of this outbreak. So I think it might have been a little bit of the SPC erring on the side of caution. It was a fringe high risk, I think, but I overall think with the verification and how quickly everything unfolded on Wednesday afternoon, I think it was a warranted high risk. That would just be my opinion.
What was the biggest storm? Was there an F5 in there, an EF5?
Biggest I've seen so far is a 2.
Yeah, I know.
Only a 2?
Yeah.
Well, one of the things I noticed that is the jet stream was right over the top of these things. Both the subtropical and the tropical jet was flowing right across Alabama over the top. Not to the north, I mean, vertically upward. And these storms were breaking through that. And I would imagine they had a lot of shear. They were a little bit too highly sheared at the upper levels to be optimal.
Okay.
Greg, yeah. That's one of the things I wanted to point out, because, the initial forecast of this was the threat continuing more into the night for the tornadic component of this. And I think that's what really warranted this high risk part, was also the like post sunset continued threat. And I think what you're saying is on the money there in terms of the shear profile and how we had way more of the linear convection earlier on, and didn't promote as much of the long-term discrete cells as what was forecasted. So I think it was I think it was a little bit of an over forecast in that sense, but I think it was warranted given the possibility of some of the more overnight. But that's a really good point, Greg, and something I wanted to look a little bit more into is the shear profile evolution more into night, how much it was compared to what it was forecasted.
Yeah.
Yep. Yep.
Okay. So I'm going to just take us through the forecast. This will be a fairly brief presentation. I didn't, of course, looked at the current weather, but just to focus on the forecast, and sort of the headlines here are really improving weather. And I think the possibility of getting, into the mid 60s over the weekend on Sunday, which is something that a couple of days ago I wouldn't have anticipated. The models are still suggesting low 60s, and we'll take a look at that. So I'll just start off with a current or near current surface analysis. This is from the GFS interpolated to the MM5 grid. And what you can see is a large anticyclone parked right over the center of our state, north central part of our state. Pretty sprawling anticyclone that goes all the way from southern Quebec, south westward toward Wisconsin, and then continuing down into parts of the southern plains over Texas. Along the east coast of the United States, you can see from the thickness pattern, those are the yellow contours there, or measure the average temperature between 1,000 and 500 hectopascal for this analysis. You can see a frontal zone that's draped across just off the east coast of the United States. And we'll see that front is still a fairly active front with precipitation along it. We're going to see a curious development over the Gulf Stream over the next couple of days, maybe a harbinger of things to come in a couple of months with subtropical development. And then finally, over the west coast of the United States, you can see this cyclone that's east of British Columbia and Washington and Oregon coast. And that's going to play a role in our weather, perhaps by the time we reach Sunday, or some vestige of this particular event. But as always, we're going to start off with our meteorogram, John Martin's favorite item on this map. So here you can see the temperature trend over the weekend. Nice step up in temperature each day. So certainly a warming trend, and also an increase in dew points over us as we see the return flow beginning to set up as that high begins to move toward our east and southeast. And you can see also for the period for the next 60 hours from 12Z this morning, we're going to be dry. So that's kind of nice. A nice weekend coming up, and deservedly nice, I think, for many. This is a time height section. Let me back it up a little bit so you can see it in its fullness. Again, yellow contours are isotropes. So you have wind as a function of height, function of log pressure, and then time runs from left to right across the bottom, so you can kind of get a sense of the time frame. Again, 60-hour forecast. The light blue contour is negative, is minus omega, so this is subsiding air in these regions, and our tropopause is located about 300 hectopascal, the dynamical tropopause. And the most evident items on this particular chart, most conspicuous, are, again, the daytime heating and the formation of what looks to be, within at least the context of this model, a well mixed layer that formed later on this afternoon. Again, Saturday afternoon and even Sunday afternoon. If you note carefully, the isotropes that we sort of mix up to 282 here, 286, and then still 286, but maybe even 288 by the time we get to this point, kind of gives you a sense of how warm we could potentially get over our region. And so by Sunday, this is suggesting that we could, if we mix up to about 900 millibars or so, 288, that's what, 15K, so we're at least 60 degrees. And that's going to be a useful thing. Often people will use a so-called 850 millibar rule, but it looks like we're not going to quite mix that far up. If we were to mix up to 850 millibars, that would bring us air that's down, closer to 65 Fahrenheit if we were to bring it down to the surface. You'll also notice we have a strong veering of winds with height. So this is going to be associated with warm advection. You see the isotropes sloping downward to the right, again, indicating the column above us warming up over time. So again, improving weather, relatively low relative humidity is only creeping up at night because of the cooling, radiational cooling at night. Again, this looks to be a really exceptionally nice weekend with breezy conditions probably developing during the day on Sunday morning into Sunday afternoon. If we look first at the forecast starting out for this evening, see the anticyclone that was over the northern part of our state is now shifted over to southern Lake Michigan. You'll see the precipitation that's forecast to fall associated with that baroclinic zone, frontal zone that's exiting the East Coast. A lot of precipitation, and a weak cyclone has begun to develop just to the southeast of Cape Hatteras, North Carolina, with a cool northeasterly flow across the eastern part of the United States, so the southeast United States coast. Over our area, again, with the anticyclone to our southeast, kind of very light winds and winds across the upper Midwest and the northern plains having turned into the southwest with a nice warm advection pattern beginning to develop. Going to tomorrow morning, that anticyclone continues its eastward move, and those southwesterlies haven't quite broken into our area yet, but these the geostrophic southwesterlies, and so but still sort of big, broad, sprawling anticyclone that's going to guarantee some nice weather for us. Cool tonight with light winds, but then tomorrow warming up nicely. And this 1017 low that's developed along the baroclinic zone with sort of heavy rain in this region. Now, I've not looked at SSTs, but I believe some of this flow, this cool air, is flowing over the Gulf Stream. And I think there's probably a role of the Gulf Stream in sort of moistening the air, sort of air, air, atmosphere, ocean interaction over the Gulf Stream that's helping to accentuate some of this precipitation. And again, we'll look at a loop of this. You'll see a nice cyclone that kind of spins up and drifts southeastward toward the Florida coast, and then eventually back to the north. The weather system that was off the west coast of the United States has moved inland, and you can see the precipitation through the far western part of the United States into parts of Nevada and Idaho and the Dakotas, or approaching the Dakotas. By tomorrow evening, again, surface pressure has dropped a little bit, 1015. Again, convection is or very heavy precipitation forecast by this model as well as others just off the North Carolina and South Carolina coast as this cyclone begins to intensify. The anticyclone is kind of blocking the exit of this system to the east and northeast, and in fact, this cyclone has kind of moved backwards southwestward over the time period that we've been looking at these maps. Pattern that we often see in the spring and the early summer, with strong warm advection toward northwest. So areas tomorrow afternoon toward northwest are probably going to be considerably warmer than they're going to be over Wisconsin tomorrow with the light winds. And we get to 48 hours Sunday morning. Finally, those southwesterlies break into our area as the anticyclone moves further to the east, and you can see precipitation beginning to develop along a developing cold front well to our west through the Dakotas and parts of western Colorado. And so this is that warm advection that's going to help boost our temperatures. As that gradient increases, we're certainly going to begin warming up and getting breezier during the day on Sunday. And then just jump to Sunday evening. There's our line of precipitation. This is a fairly active front. You can see in the pattern of the sea level pressure contours and if you look at the geostrophic advection of thickness by this wind pattern. This is this front is active. And so we're going to see a nice thermally direct circulation about this front. We'll see another way to visualize that in just a moment. And again, this very heavy rain and increasing winds along the Carolina coast as the pressures slowly follow the cyclone that's developed along the East Coast. I mentioned this is what we term an active front. So frontogenesis is actively going on it. We have a number of diagnostics we could use. We could calculate the frontogenesis or even look at the QG-Q vectors. And that shows a pattern, very nice pattern with Q vector convergence along the leading edge of the region of cold advection as the cold air is advancing southeastward. And that's certainly going to set up a line of precipitation. Again, Q vector convergence is a useful quasi-geostrophic diagnostic for vertical motion. And we can see right off the North Carolina coast, significant Q vector convergence in a region where we have the pressures already low or just to the northeast of that. And that would certainly foster a deepening cyclone if they're co-located with the ascent in the lower and middle troposphere above this developing cyclone. I'm going to do a quick loop of this just to see the evolution of that. And you can see the cyclone heading, appears to be heading southwestward and intensifying with the precipitation and the winds increasing around it. And I think, perhaps the fact that we have a pretty warm Gulf Stream in this region may be playing a role with this, as well as approach of a modest trough. And we'll see that also in the forecast as well. Over the upper Midwest, we can see the approach of that weather system from the west coast of the United States as it gets organized over the Rockies, then begins to head eastward. That band of precipitation shows up pretty nicely as well. If we look at this from a potential vorticity perspective, this is in the lower troposphere. And this is the 305 to 315K layer. You can see pretty soon into the forecast this creation of low values of potential vorticity. These are between 0 and 0.3 PV units. that forms on the north side of this, that precipitation shield associated with the coastal cyclone. And at low levels, you can see the development of higher values of potential vorticity south of that. And that's near where, it looks like there's some sort of convection occurring associated with that surface cyclone that's developing. And again, this is nothing tropical, or maybe not even probably far from subtropical, but it's in a region in a few months where we might expect to see some of these developments along old cold fronts, particularly at lower latitudes. So just an interesting development there. And again, it's consistent with development seen in the NAM and to a certain extent in the GFS. So just something to watch for, in the news, you might see some coastal areas impacted by heavy rain and strong winds later this weekend. But for us, it looks like we're going to stay relatively dry. If we zoom into Sunday evening, this is the 60-hour forecast. You can see those fairly brisk southerly winds at 10 to 15 knots. And you can see the band of precipitation with a cold front to our northwest. That's pressing eastward, and pretty breezy conditions, but we're going to stay dry through Sunday evening. And it's probably going to be early Monday morning when we actually see some precipitation. This is another animation. This is the NAM. And you can see, again, pretty much what we see in the MM5, although the retrogression or the progression southwestward of the cyclone at the beginning of the forecast loop is a bit more apparent, far back to the east coast of Florida. And again, a broad sprawling area of precipitation north of it. And then this begins to deepen, continues to deepen, and you can see the strong winds associated with it along the Norfolk, Virginia, Wallops Island area as that cyclone intensifies. Closer to home, again, here's that precipitation arriving or approaching our area. And I'll back it up a little bit, because even by the time we get to 60 hours in the forecast, this is the time we saw on the MM5 forecast. If we were to extend this a little bit further ahead in time, precipitation, interestingly, and I haven't done a deep dive into what happens here, but it seems to sort of decay as this weather system approaches us. And it could be that the frontogenesis is just weakened over time. And so we don't get much in the way of precipitation. In fact, the front hasn't really gone through us in any obvious sense until we get to later on Monday evening. So this is Monday, it's I guess 5 p.m. So again, questions or comments, certainly they're welcome. And then we can look a little bit further ahead in the
just going to say, Michael, about the storm off the coast of the Carolinas. That's really interesting. It's caught on the equatorward side of that big anticyclone. So it looks like an easterly wave by the time it gets back to Jacksonville, and then it just gets carried northward by the upper
westerly.
That's really, really interesting. It's right about at the latitude where they stop behaving like easterly waves too. Isn't that funny?
Yeah, I mean, it's maybe not so much, I would differ a little bit, maybe not so much easterly wave-like, but in terms of its progression, maybe that's what you're referring to, the progression of this sort of against the flow, against the shear. I guess they call them reverse shear types of disturbances. This thing's sort of propagating seemingly upstream. Yeah, that's the really interesting feature there. And again, if you look at it within the context of the GFS, maybe less robust than that. It has a lot of different centers, but it develops one just down along the Florida coast. And actually about 2 weeks ago, the ECWF developed a pretty definitive subtropical cyclone in that region. So the same type of weather situation, but it had a totally different evolution.
Yeah, so one thing that comes to mind for me is that if you have a little bit of a convective organization there, and that stretches the column and generates a local vortex, and you have shear that's going exactly towards the east, then isn't that right? It's easterly shear, I think, there, because it's on the south side of the anticyclone. Maybe I don't see the thickness lines well enough, but it looks like the PVA actually compels the thing to move back to the west.
That's probably right. I'd have to, let's take a look at that. That's a fairly straightforward thing to look up. And I'll stop this animation. I'll just look at, say, 24 hours in the forecast. But I'll go to the NAM where we actually have the disturbance set up. Right. So the shear is still going to be.
Oh, it's westerly still. Yeah. Okay.
Yeah, it's westerly shear.
Yeah.
But the, I guess at low levels, the airport. Oh, I'm just trying to think of that. I'm tipping my fingers. We have the precipitation that's occurring at low levels. Though it would appear that these air parcels are approaching from the east and going through this wave. Yeah. So didn't mean to do it. I didn't want to do that. I have to think about this a little bit more in terms of its setup. But this is, again, a really interesting development if it actually occurs in the model. And we'll see that in the forecast. We'll see it in the observations over the weekend. But generally, nice weather coming up for the weekend to round this out. And then if we look ahead for the rest of the week, and I'll just do this in really quick, 72 hours, the precipitation hasn't quite gotten to us here with a front, kind of stalls. But then a day later, we get a fairly significant precipitation event, if this verifies, over us on Tuesday. Pretty nice spin up of a cyclone and just a wet period. And then with cooler weather, cold advection coming back in as the front finally moves well to our southwest on our southeast on Wednesday. Thursday's chilly again, and then a big rain event in the southeast United States becoming a snow and ice event in the Ohio Valley in the northeast by next week. So that might be what we're talking about at Weather Watch next week.
Yeah.
One very last thing that I think is really neat about this development, this weather system that comes out of this, from basically this blossoms out of Mexico as it's moving northeastward. You can see all this convection around the cyclone. This is a map by Tomer Berg. There's a nice website at OU. This is the dynamical tropopause. If I advance this to about 144 hours, this kind of links into the discussion we had earlier, John. You're asking about the convection and the role, what happens to the upper troposphere. It's interesting as this wave that you can see in the dynamical tropopause moves eastward. So what this map is showing is dynamical tropopause potential temperature and sea level pressure below 1,008 hectopascal. You can see it kind of comes in as it begins to interact with it. You see this explosion of red colors here that didn't quite exist before. There's a little bit, but again, that indicates non-conservative effects occurring. This is the effects of the convection distorting the dynamical tropopause. This is really low PV, would probably be low vorticity air in the upper troposphere over this region, which again, getting to this turbulence and sort of inclement weather for airline flights. And you can say, well, it's nice to show that, but is there any evidence that there is significant precipitation down there? This is 138 hours, let's say. And here we are, 144, 138. You can see the development of this convection as this wave approaches along the dynamical tropopause. And here's the convection that's again, it's the same forecast. Tomer Berg's maps are from the GFS, so it better be consistent. You can see where these convective elements were occurring. That's going to have an impact on the dynamical tropopause. And there's changes in vorticity, changes in potential vorticity, certainly in the upper troposphere. So the impact of convection on these surfaces shows up nicely. But anyway, that's it.
Can I say a couple things?
Yeah, please.
I just noticed that over this next week, it looks like the polar vortex is on the move again. It's been sitting over Asia for the last 2 or 3 weeks, maybe a little more, since we warmed up and we got rid of the real cold air. It's been sitting over Asia, and it seems that over this next week, can I put up a screen for a minute?
Yeah, sure, please.
Share screen. Do I go to advanced sharing? How do I do that?
Should be able to
Share
just click on
screen?
your screen and choose like desktop one.
As I say share screen, it says one participant, multiple participants, advanced. Am I cleared to share the screen?
Should be just on basic. You should be able to just do basic share your screen. Yeah.
Hey, Greg, you have to try clicking on the middle of share screen and not that little arrow. That arrow is the settings.
Oh, the middle. Oh, yeah,
you should be able to get it.
Yeah.
Yeah.
Okay. All right. Yeah, share. All right. Okay. So this is the desktop, and this is the jet streams from this morning, midnight last night, and then I got the forecast for the next week. And this donut here is the polar vortex. You can see CONUS down here at the bottom. This is a global map. And what's happening is this polar vortex now is intersecting with the subtropical jet here over very eastern Asia. But I'll just animate through it, give you a view of how that's looking. And you can see as I animate through it, it's moving off the pole now and heading over into the Western Hemisphere, the polar vortex. And at the same time, if I stop it at the very last frame, which would be Yeah, come on. Okay, so here's the last frame. This is Saturday next week. What's interesting now is we have this over here is a low-level polar jet right here, and a polar night jet. The polar vortex is over here, and in the northwest. Now what we see is an intersection or a combining of the polar jet and the polar night jet in the Western hemisphere. When we see this kind of effect, so what you're doing here is you're looking through the top of the polar night jet and seeing the bottom of the polar jet in here. So they've got a continuous jet stream all the way up from low levels all the way up into the upper stratosphere. And when you get that, it tends to amplify things. And you can see this is associated with a ridge that's dropping cold air into the middle of the country. Sometimes when we see this, that can generate much stronger cold air outbreaks in the middle of the country. And I'm not sure in the longer run where this polar vortex is heading. It may be heading more to the center of CONUS. I don't know. But even at this point, it looks like it's going to open the gates for cold air to drop into at least the center part of the country at the end of next week.
Yeah, that's ugly.
It's ugly. Yeah, it's ugly. I mean, we're hoping for warm weather, but this pesky thing does come back a lot of times and get us in the spring.
Yeah. And the fact that it gets wavy right at the right time and in the right place to drag the cold air southward is quite interesting set of circumstances. I don't know if they're interactive, but I wonder if they aren't.
Yeah, I think they probably are when you see it this much. This is one of the strongest interactions I've seen in the last few weeks. So it doesn't look good for sustaining warm weather for a long period of time.
Yeah. What's the time? What run was this from?
The 6Z this morning.
6Z.
I have a 12, or maybe, 6Z. The 12Z didn't work. Pete, the files aren't coming in again. But yeah, that's from 6Z last night.
Because I could show you the forecasted temperature anomalies at the surface, kind of over the northern hemisphere from that period forward. That's about 180 hours forward.
Okay.
We get cooler, but not significantly cooler. Again, this is pretty far out. Let me get the share button.
This is nothing compared to your 376-hour fantasy.
Hold on a sec. Share screen. I think this is coming up. Oops. Wrong window. You can see the map, right? Okay.
Yeah.
So Greg, you were looking at, so this is from the 6Z run of the GFS. This is at 180 hours. So it goes to, I'm just trying to line it up with the time that you were showing at the final time. And these are 2 meter surface temperature anomalies, or 2 meter temperature anomalies for next Saturday. But you said it's probably how long before we'd expect to see the cold air kind of coming in?
It would be after that, probably.
Right.
But looking over the next couple days.
Right. So that's next Saturday. And then you can see it does get colder over northern Canada.
Right.
I'll just jump ahead. That's Sunday, even colder. So it's, we'll get down here.
Here it comes.
Getting pinched
Close
out.
to
At least in
10 days.
Canada.
Yeah. Ooh. So let's go back a little bit and see that. It's surprisingly cold down here, and where that comes from, I'm not certain, but they do seem to join up, and you're getting a pretty large thermal anomaly. Well, down in Texas, and that's can't get these colors are about what 12 degrees below normal down there.
Mhm.
For us, it's I can actually let me just zoom in back to national map. Actually, 27 degrees.
That's
Cold
energy crisis again for them.
Yep. They're going to be turning the heat on. And then for us, about 8 degrees below normal. So this is, yeah, there is something there, Greg, at least in that particular forecast run.
Yeah.
Fortunately, not long lives. So.
Yeah, well, the vortex is on its last legs by early April, so it can't really hang in for too much longer.
Are we getting it
I
recharged?
think it usually is, John, if it's sitting over the pole, but it's not. It's not sitting over the pole. It's on the move, and it was dislodged with the sudden warming earlier in the year, and it's been kind of, toroidally going around.
Yeah. But the
Um,
further south it goes, further south off the pole, the more the insulation destroys it, I would think, but I don't know.
Yeah, I don't know.
Right. So that was a 6Z run. And if we just go to 12Z, I wonder. Okay, so this is the same run or the same model, a run 6 hours later. It's the cold air further to the east. But there is a notion of our getting colder in a little over, just beyond a week to 10 days out.
April
So-
Fool.
I think when the polar vortex, in the years where we have sudden warmings earlier in the year, we tend to stay colder late in the spring. And I think that has to do with shifting the polar vortex off the pole. And if it was sitting at the pole, what would happen is it would shrink back. It's shrinking now, but it would shrink back to a smaller diameter where it no longer intersects with the polar jet, which disappears at lower latitudes. And then we just are in a void where there's no connection. It gets warmer. But now, because it's kind of going around in the northern hemisphere flow, it's continuously intersecting as it goes around with the polar jet. And I think that's driving more cold air south.
So even though we'll warm up, don't count on it staying warm, is what you're saying.
Yeah.
Yeah,
Sounds-
well, it makes it more variable and brings us into cold to warm to cold, and doesn't let it just keep warming.
Right. Okay. Really interesting. Let's see how that looks a week from now when we for
Yeah.
Weather Watch. Unfortunately, I will not be able to join Weather Watch next week because of a meeting. But yeah, thanks, Angela and Andrew and John and
Yeah,
Greg
thank you,
for
Greg,
the discussion.
and Angela had to leave, and Andrew, great job today. That's fantastic. So it was really,
Thank you. Thank you.
Good.
really good.
Yeah,
Thank
really
you.
good, comprehensive.
Go
Anybody
back.
wants to take the lead on the forecast for next week, since Professor Morgan won't be here, have at it. It'd be good to have somebody else
Hmm.
do that.
Okay.
Yeah, if
All
no
right.
one else does,
You start traveling again, Michael?
No. This is just a AIP meeting.
Oh,
That's going to be Thursday, Friday.
if nobody else does, I'll have to be showing those meteograms.
Meteorogram. Meteor. You got to kind of talk like you have marbles in your mouth as you say it.
Yeah, and when you lose all your marbles, then you can say meteorogram.
And then you're on
All
a
right,
roll.
I gotta jump off. Have a great weekend, guys.
Okay, thanks.
Yeah.
Thank you, Andrew.
Andrew,
Good
Go back,
discussion.
Andrew.
I got to go too. See you guys.
bye.
see everybody.